and we are here today to discuss with you an effective learning map, an effective roadmap if you want to learn AI today. It depends if you have previous experience with whether software engineering or data science or data analytics. So if you are coming from one of these fields and you are looking to upskill yourself in the AI field, we are here today to discuss with you a roadmap that would help you to stand out in the market and get a job in the market as soon as possible. All right, so without further ado, let's start with our presentation today. So my agenda will be, I hope it's gonna be a light agenda for you. So we are going to discuss what's machine learning engineering, what's the AI from a broader view, and then what's the ML ops, and how does the machine learning engineering and ML ops developers work together. What are we offering at WeCloudData for our learners? What's the learning journey, what the curriculum looks like, and what are the benefits that you are going to get from learning at WeCloudData. Okay, so I can make a fair assumption that all of you are interested to some extent in the machine learning engineering, but maybe you are overwhelmed by a lot of concepts and definitions here and there about what's the machine learning engineering, what's the difference between AI and machine learning and deep learning, and then we have a lot of advanced topics that are coming new every day. So basically, the bigger umbrella of the AI, which is going to be consistent in two ways, but the main object for the AI is to make the computer trying to make their own decisions, like what we are doing as humans. Okay, and we have to acknowledge that we are not in competition between the human race and the computer. And there is no war at the end between both of us. It's more of an evolutionary stage in the computer science field, and we are trying to enhance the capabilities of the computer and software in general to be able to try to make this kind of decisions. Okay, the decisions could be coming from two ways. The first one is it's going to be what we call a rule-based system. So we are going to give the computer some sort of rules, and the computer would be able to make decisions based on the rules that they have been explicitly computerized or programmed to do. This is the what we call the rule-based artificial intelligence. We can give a clear example if we have just a chatbot, and this chatbot is just programmed on several points. It's not anticipated to come up with a new or any untrained on scenario. This is something different from ChatGPT. This is maybe could be in a sample website, maybe your favorite restaurant website. You are going to ask, are you still working? They are going to reply, yes, we are, or no, we are closed, based on the time factors that which one of the rules that the developer built in. Or maybe we can update the system and telling them, okay, we are sold out today after a certain number of orders. So either this way or either that way, this is more of a rule-based system. So the computer is not replying from their own or based on what the data they got. And this is the bigger umbrella. And then this is not enough for the computer capabilities and what's really the computers are powerful to do. So we move to the machine learning era. So the machine learning is basically that the computer is going to see a lot of data, historical data, and trying to identify some underlying patterns between the data. So if this pattern, it's not easy to be detected by humans. That's why we are trying to use a lot of statistical models to be able to predict this kind of sessions. For example, if you are talking about what is the price of for example, 2022 used Corolla. So based on, you can have some biases if you are loyal to Corolla and you love Japanese car, and you can overprice it, or you can underestimate the value of the car. But who can really tell us the fair price of these cars? If you are expert in this field and you have knowledge about all the cars in the market and the different conditions and what is the fair value for each one of them. So this is the normal task, which we call one of the regression tasks. So this is a task that we could do as human. So the challenge is how we can make the computer powerful enough to take the decision and give us a very good estimate about the price of, for example, a used Corolla. So what we do normally, we are going to provide the system with a lot of information about the car, how we are predicting the value of the car based on the mileage, based on the condition, based on the year, model, make, all of these things. So all of these factors, it has a relationship between them and the final price of the car. Maybe for the human, we are not 100% sure what kind of relationship underlying between them. So now we need the computer to be able to identify all the patterns and get the final output at the end. So this is the second layer of the AI, which is the machine learning. Okay, this is what great at the time, but this is not great enough for all the ages. That's where we tried deep learning. So basically, the deep learning is we are going to do what we did in the machine learning, but multiplied by maybe 1 million times at least. So this could be used for a computer vision task. This could be used for the NLP, which we are going to ask the computer to try to use the language in a way that we are the human used. For example, we can go back for the maybe at 2010 or maybe at the beginnings of the 2000s, when we used to use the first version of smartphones, and all what's doing, it was just predicting the next word. This is kind of an NLP task, and this requires a lot of training to just being able to predict the next word. When you say, for example, good, the next predictions could be morning or evening or night or boy, but it couldn't be something else or something irrelevant. It's not a rule-based. We are not letting the computer knows that every time people are saying good, here are the possibilities. But the computer is learning this by extracting a lot of text, which we call corpus. So it's extracting this text and trying to understand the patterns that's happening here. So this requires a lot of resources and better capabilities, better algorithms, how to deal with this. This is the deep learning. So I hope this can show you the boundaries between artificial intelligence, machine learning, and finally the deep learning. So basically, we are doing analysis, doing problem solving, and now the deep learning is going in fields like the NLP and computer vision, and these are the main two sections of the deep learning nowadays. You can think about all the devices or smart things that you are using in your daily life, and you'll find that, okay, now the AI is about analysis, image analysis, video, maybe analyzing also the waves, which is coming from the voice or the audio. And the second part is how to predict more words. So this is the main two branches of the deep learning, the computer vision and the NLP, and we are covering both of them in our curriculum. Okay, so now it's all about how to develop and prototype a lot of business solutions that could tackle different business challenges in certain areas. Like, for example, what are the latest advancements in the field of customer service or biomedical services? All of these services are right now looking to get more solutions that are AI powered. And I'm sure that if you are coming from a business background, you might find this is on a high demand nowadays in the market. So the role of machine learning engineering in general, it's about addressing pain points in an existing system. So it's not only about creating new tools or creating new systems. As I mentioned, every business aspect nowadays is looking how we can be AI powered, how we can use the NLP capabilities or computer vision for our daily tasks, how we can for example, if you are working for a company that's you need to maybe scan personal IDs, public IDs, I mean, like driving license or something like this. So it's not only enough right now just to getting this data to be written by a human people, but now we are looking to getting a software that's going to be integrated to our existing solution to be able to faster this process by scanning the public ID and then being able to extract the entities that are there, where we can find the name, where we can find the address, how not to confuse the address with the name. For example, if someone is living on Young Street and part of his name is included Young, so how the system can distinguish this is the address and this is the name of the person that we are looking for. So we need to increase productivity and doing better operations. You might come across a lot of softwares today that could help you manage your daily tasks, helping you to sort out what should you start first, how you can delegate your tasks. There's a lot of apps in the market for this purpose, how you can build a better product and enhance the service that you are offering. And at the end, how we can make a well-informed and data-driven decision, which is something it's very, very important nowadays for the business world. No one wants to waste resources because of the full image is not clear, and we just need more time to understand the situations. Everyone is looking for data-driven sessions, and the way to create data-driven sessions is utilizing the historical data and being able to making sense out of this data. All right, so this was one part of the story, but it was to mention that only 22% of the companies in the market, they are actually delivering a solution. And there are a lot of challenges that's happening. And it's not only because of building the model and how complicated is the model. And on average, it takes around 9 months to develop an AI initiative. And this is according to Deep Learning AI, which is a leading foundation in the AI industry. So right now, a lot of organizations, they are looking to implement a lot of AI initiatives, but they are struggling to do so. And the complexity is underestimated all the time. All right, that's why we are trying to use MLOps. So MLOps, it's basically machine learning operations, and we are trying to get things done because, as we mentioned, it's like a 20% chance for one project to survive and to go to the market. Not speaking about how many of them are going to be viral or generating billions of dollars and being a unicorn. This is another topic, but at least you need to understand that data science is not only about building models or creating algorithms. Data science and machine learning engineering specifically, it's about how you can create the whole system that could serve millions and billions of users like what we have nowadays. Okay, so the MLOps, it covers a lot of things, starting from planning to the project, how we do the creation of the project. It's normally a main task for the modeling part, how you can build as I mentioned, computer vision algorithm or NLP algorithm that could work on one of the tasks. But then you need to work on verification and packaging for the models, how to you can release it, how you can do certain configurations to make sure that that model is going to serve people using different devices and using different what kind of system that you are inside. Are you inside a very speedy system or a system with intensive users? How you can do monitoring for the performance of your model, and how is the model is really performing actually in the real life. All of these parts are not only about machine learning algorithms or data science. Here are a lot of things about the MLOps, which is the machine learning operations. So the machine learning operations, it involves learning a lot of tools like Docker, Kubernetes, Jenkins, AWS, cloud computing in general, Airflow, a lot of tools that would help you to serve your project better and being able to deliver the service that you are looking for. So when we are talking about a lot of tools, we should learn how we can harmonize these tools and know when and where to use each one of these tools. And this is the major task for any machine learning engineer. Okay, now you might be overwhelmed by a lot of job titles in the data team, like for example, data analyst, data scientist, machine learning engineer, data engineer, machine learning operations, or MLOps developers, and you might not be sure which one is the best one for you. So I want to give you one of the examples, and this example is coming from different companies. It might be not 100%, I wouldn't call it accurate, but not 100% explaining what happens really in the market, because at the end of the day, every company is doing their own definitions based on the app that they are working on and how complex is the operations on their sites. But let's have a clear example about, for example, maybe we can start with Uber Eats. So if you are using Uber Eats, and Uber Eats are sending a lot of requests and a lot of data every second to their own backend. So the running system, which is going to be, for example, Uber Eats, are going to send a lot of data, and this data needs to be maintained, ensured its quality and integrity of the data that is provided, and we should be sure about the pipeline that is going to collect the data and how it's going to be stored in the data warehouse. So for managing the data warehouse, we will have data engineers who will be responsible for this point. And then after we have the data stored already in our data warehouse, we would need a help from who are we calling data analysts. So the data analysts are going to get us some PI reports. And the purpose of PI reports is trying to understand what's happening on the system, what's the major issues or challenges that are facing the clients right now, and how we can improve it. So they would be looking for the data and trying to get more business questions, like, for example, why the orders are taking too much time. This might be a technical question, and this might be user experience questions, or it's all about supply and demand. There are too many factors. So the PI team are going to get this business question and trying to provide answers based on the data they have from the system they are working on. After they completing the report, the data scientist would be working on building the models. How we can, for example, increase the rate of ordering 1.5 times. So this might be the challenge. So they have to come up with a lot of models that could serve this solution. So they can see, based on the report that we got and on our understanding for the customer, the main issue is that if you are a regular customer that you are using Uber Eats every day, and you open today, you are not seeing the best recommendations for you. So this is the first part of the solution could be enhancing the recommendation systems that we have. Then maybe because of the data they have, they might understand that you are looking for some offers to increase your order or to cut time the ordering period that you need to make your session. So they might come up with a lot of models, and all of these models should serve one point of the main issue until we came up with the solution. Until this point, the user doesn't feel anything, and there is no enhancement on the user side. All of the work that I mentioned is happening in the background. So after they build the model and they sure that this model is robust, they are providing the models for the deployment part. And machine learning engineers would be taking care of how they serve the model, how is the model is really actually operating on the user side, what kind of feedback that the model is returning to the system. So this should be the next points for optimization and building a better models. So as I mentioned at the beginning, the boundaries are not very clear between each specialization and the other. So you might notice that this is not the case for every company. So for some companies, the machine learning engineers are supporting in the data warehouse, or vice versa. The data engineers might be working on the deployment because there are a lot of tools that are in common between them. And the same goes for the data scientist might be able to support in the reporting and building the PI reports. It could be some data analyst might be experienced enough to do some modeling, but this is not the core business of data analytics or the data analyst. So it might be, but this is not the standard case. So this is to give you a better understanding about what are the different roles in the market and which one could match your expectations, what kind of background that you have in terms of education and your previous experience as well. All right, so who is WeCloudData? So WeCloudData, we are a Toronto-based Toronto Institute of Data Science and Technology, and we are based in Toronto, but all of our training right now is online. That's why our team is expanding globally, and we are doing a lot of corporate training beside training to clients. And we are serving different kind of clients on our big portfolio. So our portfolio is consists of different projects, different trainings and boot camps. We have trainings related to data science. We have trainings related to BI and data analytics and data engineering as well, and finally, the machine learning engineering. So we are serving our model, our boot camps in different formats. It might be full-time diploma, part-time. It could be also self-paced training. We have a lot of variations about how we are delivering our content, but we are making sure that the content is really well-served and delivered to our students. So the machine learning engineering bootcamp, it's about 6 months, and it's on a part-time basis. And we are teaching 3 main topics. The first is computer vision. The second is NLP, natural language processing, and large language models. And these are the hot topics in the market right now. And finally, the MLOps. And we do have a unique package. So if someone is interested to do the full boot camp and getting the 3 courses, they are welcome to do so. Or if they are just looking to upskill themselves in one area, they can go for one of the short courses of these courses that we have. And yes, as I mentioned, we have the course is around 6 months. but we are serving different options. So, for example, some of our students might be just interested to get a part-time training, and maybe they are working for existing companies and they are not interested to do real client projects. And others might be looking for the course plus the real client projects, and also we can have students who are just interested in doing real client projects with real clients from the market. So for all of these scenarios, we are prepared with different packages that could serve every one interest. Okay, so to cut it short about the machine learning engineering bootcamp learning outcomes, or the student journey, how it looks like. So first of all, you are learning from experts in the market. All of our instructors, they have years of experience related to the topic they are teaching, plus having higher degrees like PhD or master's degrees related to the AI. So our content is up to date, and we are covering advanced topics related to computer vision, like GANs, generative AI, and for the NLP, we are covering large language models and machine learning operations as well. So while you are completing the diploma, you will be working on portfolio projects. One of them related to computer vision, the other one is NLP, and any one of them could be deployed, and this would cover the ML ops part. So it's more of an end-to-end experience, starting from building the models and then learning how to serve it to the cloud and being able to be used by the end users. And also we are having real client projects that we are include our students in, and these projects are coming from the market, and there is a company behind it. So our students, they are getting a chance to get, you can call it an internship while they are having the boot camp. So they will be dealing with a real business case, and they will see what kind of technical challenges that's really existing in the tech market, and they will be able to come up with solutions to serve this challenges. Besides, we are providing 6 months of career mentoring to make sure that our students can compete in interviews, when it comes to doing a technical interviews, and providing the resume and all of these things. All right, so as you might get, WeCloudData, it's not only about the training. We have a complete ecosystem that's going to serve the students. We have corporate trainers, and we are in deal with a lot of corporate clients. So our students are getting the needed exposure from the market about what kind of the projects that they have. We have a lot of mentors, so they can discuss with the mentors about different learning opportunities and different working opportunities as well. And there is a network of WeCloudData graduates. They are going to be part of this network to engage with another alumni from our program. As I mentioned, it's about 6 months, and the 6 month is divided into 2 main weeks, 2 main semesters. The first one is what we are calling deep learning, computer vision, and NLP. And the second one is the machine learning operations. And once the students are completing the bootcamp, they would be directed to the client projects and then getting the needed support to do job search. So before starting our bootcamp, we having an initial meeting with all of our prospects. We are discussing with them about the bootcamp. We are trying to set expectations, realistic expectations about how we teach, how the course looks like, what is the details of the content that we are covering. So this is to ensure that our students and prospects, they are aware about what they are going to have during this bootcamp, and also to make sure that we are aligned in terms of the expectations, and we are sharing with them realistic expectations as they need. again, this is more details about the curriculum. Machine learning foundations, deep learning foundations, computer vision, NLP, and ML ops. And here are a sample of the topics that's already covered in our module. So the next cohort is going to start in less than 1 month from now, which is going to be May 23rd. And our lectures, it's starting around 6:30 evening on Thursday and 9 a.m. in the morning on Sunday. This is Eastern time, and we have office hours and labs, and this is going to happen on Sunday from 1 p.m. to 5 p.m. and the office hours happening on weekday evenings. All of our students are getting access to our learning management system, which can keep them updated about what are we teaching, what are the previous lectures that they had, and they would be able to interact with the TAs, submitting their capstone and their assignments and doing quizzes as well, to make sure at the end they are getting a complete learning journey. For the market insights, right now, the average for machine learning engineer on the junior level in Canada is around 100K, and in the States, it's between 110 to 130. And we are proudly to say that we have a 98% of the placement rate from WeCloudData alumni, and all of the students are getting real data jobs, so we are not reporting any other kind of jobs to be included in our placement rate. And Indeed has shared the top jobs involving in the AI, and the top of them is the machine learning engineer, then a deep learning engineer, senior data scientist, computer vision engineer, and as you can see that 3 of the top 10 jobs in the data world are covered already in our boot camp, especially the machine learning engineering. So you might be able to do a lot of roles in the market, plus the ML ops, which is experiencing high demand these days. So starting from the end of, so the demand increased for machine learning engineers starting from beginning of 2016. And for the machine learning operations, as you can see, it's starting from here, and it's still rocketing because of more people are looking to having more machine learning models nowadays. Everyone wants to incorporate a lot of machine learning and AI powers to the existing system that they have. That's why the machine learning operations are on high demand, because also this skill is not learned in the universities. So in the university, if you go to traditional university to learn machine learning and AI, the majority of work will be focusing on building better models, because the university is doing research, and the research area has a lot to discover and to work on in the computer vision and NLP parts. But on the ML ops side, it's more of the engineering side, so it's not really well served in the traditional universities. That's why people who are looking to work for the ML ops, they are required to get some sort of additional training and dedicated courses for that purpose. Okay, and this is to give you a better idea about any project that's going to be in the machine learning field. At the first glimpse, everyone would think that the most important part is to build the algorithm, which is going to be either computer vision or NLP or different kind of tasks. And the purpose and the most of the time that we are going to spend in building the models. But this is not the real case, or the what's happening in the market right now. The machine learning project, it looks like this. You have a lot of things to be done. One of them, it is the machine learning code. although it's the most important one, because if you don't have a code, you don't have nothing to deploy, right? But on the other side, it needs to be uh, involved. Plus, you need to focus on too many things beside the machine learning modeling. And right now, with the use of the transformers, if you have came through this concept before, the transformers is offering us a lot of models that is actually trained on existing cases or data set with and they are very powerful. So our job right now requires us to utilize all of the models that are already pre-trained and not to waste the company money on retraining model that's it's already pre-trained. One of the examples is ChatGPT, for example, or GPT-3 and GPT-4. So GPT right now could help you build, for example, a chatbot in a minute. So why do we have to go through a very long process of training a model how to understand words and how to respond, while we already have GPT, Llama, Falcon, and all of large language models that are already in the market. So we need to learn how to utilize the pre-trained model and then need to learn how to serve this model, deploy it, and offer it to the clients at the end. And also for the job market, the most required tasks, as you can see, or knowledge areas to be covered. Sorry. For the machine learning engineers, the majority of work are done by Python. We requires a lot of other tools to be learned: Spark, AWS, Hadoop. We are covering all of them in our course. Plus, we are providing real client experience at the end of the course to make sure that our students are getting what they are looking for. The majority of work is done on Python and TensorFlow, and these are main topics that are covered in our training modules. That's everything I want to mention today, and I hope you liked the session and getting a better understanding about what's happening in the market.